Hey guys, this is the second part of making an adventure visual game in Godot. If you haven't watched the first part, you can still watch this video if you're only here out of curiosity. Otherwise, I would definitely recommend starting from the first video, let's say here, if I can figure out how to make a link on YouTube, but you can also find it on my channel. To be honest, originally I wasn't really sure if I was going to continue this series. I didn't know if this type of content would generate enough engagement for me to complete the game start to finish. There's also a couple of other themes I'd like to make videos about, but I've received a few messages from people very kindly asking for a second part, so let's continue. This time I'm going to do things a little differently. In the first video, if you remember, I took a very hand-holding approach, commenting on every step while I was building the game on Godot Live, but you might have noticed this made the video pretty long. Plus it takes a lot of time to prepare everything beforehand so I can keep a consistent pace through the video. This setup isn't super sustainable. There's just way too much stuff for me to do to keep everything real time like that. I would end up making hour-long videos or make this series go on forever. So for the second part, I'm trying something different. I have pre-recorded everything that I want to show you, and I'll play the clips, some sped up, with a voiceover so I can explain what I'm doing. If you prefer a more step-by-step approach, feel free to watch this video again at a slower speed. But I would really recommend watching it all the way through one time, getting a feel for the logic of the game engine, and then trying to recreate things on your own. In my opinion, that's the best way to learn. And if you get stuck on anything, you can always come back to this video and check the parts that you might have missed. As a side note, this time I will do my best to provide all the assets that you need to follow this part of the tutorial in the description, but you're free to use any image or sound of your preference. If anything, I encourage you to experiment with other assets. Let's get to it. As a reminder, here's the kind of UI and game feel we're looking for. We want a background, an animated dialog box, an animated character sprite, and of course, some really polished sound design. If you followed the first video all the way through, you should have something that looks like this. We've got the very basic elements in place, everything that needs to be displayed is there, but everything is still static and unresponsive. In this second video, we're going to take things further by making our game responsive and display a real dialogue. Here's what we'll be adding. In Ace Attorney, every character displays a wide range of emotions, or animation as I call them. Even their idle stance is animated. We will start by adding some animations for our current character. Then we'll add another character, Trucy if you're familiar, and we'll add some animations for this character as well. We'll add a sample conversation between three characters and set up the code to process and display each line of dialogue. We will also enable the player input to progress through the dialogue one line at a time. And finally, we'll add the logic to switch the character sprite based on who's currently speaking in the dialogue. Before we jump into it, I want to talk about the importance of having a well-organized file tree inside of your Godot game project. If you're only prototyping or having fun, this is irrelevant. But as your project grows bigger, if you put everything inside of the root folder, you will quickly lose track of what file does what. I encourage you to follow this file structure while following this tutorial. I think it's pretty self-explanatory, but if you're confused about some of it, I'm adding a description to each folder, and you can pause the video if you need some time to read it. We'll create two characters, Phoenix and Trucy, each with two different animations. An idle animation, where they simply blink, and a talking animation. First of all, how are all the characters animated? Just like anywhere else, a 2D animation in video games simply consists of a list of frames chained together at a certain speed. These frames can consist of any sort of 2D art, hand-drawn or pixel art. You just want to make sure you minimize the changes between two frames so that you can really sell this idea of movement. The more frames you add, the smoother your animation will be, but the more time and space it will take. In old 2D games like the first Ace Attorney trilogy, the animations were very simple, only a handful of frames per emotion. Godot makes it very easy for us to create animated character sprites in a game, with its dedicated Animated Sprite 2D node. To create your animation, you'll need to add either what we call a character sprite sheet, which is one sheet containing all of your frames in one image, so that you can save space and have everything in one place, or a list of images. Here, we'll choose the easier method, which is a list of images. After creating your Animated Sprite 2D node, in the editor, click on New Sprite Frames. In the panel that appears down there, you'll be able to create all the animations you need for your character. First, we'll create an animation corresponding to Phoenix's idle stance, where he simply blinks. Rename the default animation to idle and simply drag and drop your frames inside the panel, making sure all of them are in the correct order. In this animation, we want Phoenix to close and open his eyes. This means that the frame for the eyes half closed and the frame for the eyes fully opened can be reused a second time at the end, as such, to have a full blink animation. You can adjust the speed or FPS of your animation to your liking. I chose 10 FPS because it seemed to be the closest to the original animation. Now let's add a second animation called Talking and do exactly the same steps as for the first animation, with the frames corresponding to the character speaking. You'll notice that I am reusing some frames here as well to make it longer. You're free to change the frames the way you want, but ideally you don't want your animation to be too short in this case. I chose a speed of 7 FPS for this one. Now that you're done creating the animations, there are two things I should mention. Currently your animations live inside Godot as part of the game project. If you were to save your character scene, close it and reopen it, your animations will still be there. However, I always prefer saving them in a separate file so that it can be reused when I need. Right-click on sprite frames in your editor, choose Save As, and name your file accordingly to do so. The second reason why we're doing this is because we will reuse our character scene to configure our second character, Trucy. This is the reason why I named this scene Character and not Phoenix. This is called abstraction, which is a concept you'll find in various technical domains, whether it's game, web development, or anything else. This is a fundamental principle of object-oriented design, where you create a base template that contains common elements and behaviors, and then you can instance or inherit from it to create specific characters. Here, we want our character to contain the subnodes and code that will be common to all of our characters, and as such, the sprites corresponding to one specific character don't need to exist inside of it. We'll take care of reloading the adequate animations when it's time to do so, now that we've created them. Right-click on sprite frames, clear it, and create a new one. You've guessed it, we will now do the exact same process for Trucy. Let me speed up this part of the process, as it is exactly the same as for Phoenix. When you're done, do not forget to save your new sprite frames, or you will lose your animation data if you choose to clear it in the editor. On that note, you can choose to clear the sprite frames here if you want, but you can also choose to leave the Trucy animations loaded for the sake of visualization. You can see it as dummy data that will help you see if your character scene works as intended. It doesn't matter that it's Trucy's, because we will procedurally switch to the adequate sprite frame file in the code later on, when we want to display another character. Now that we're done with our characters, let's move on to the dialogue. Now, in reality, for this kind of games called visual novels, you would use some sort of scripting language like ink to write your dialogue. If you don't know what it is, you can imagine scripting languages as something halfway between a regular script and a programming language. It will contain your script along with specific character or words for your program to know what's happening. For example, who's talking? Is the current line conditional to the player having made a certain choice beforehand, etc. Another example is, if your visual novel offers the players to choose between several responses, your program needs to know where to jump in the script, depending on the player's choice. I assume the developers of Ace Attorneys had their own scripting language. You can also create your own if you're interested, and if the series continue, we will probably do so as well. But for now, we'll keep it extra simple and simply write our script inside the code. If you execute your game or your main scene right now, you should see Trucy with the one line of dialogue we have, with no way of interacting with anything for the moment. Rename your main scene's 2D node to main scene. We will attach a script to it so that we can code the logic to process dialogue. First, you'll see me rearrange my file tree a little bit. If you haven't done that already, create a folder called Scenes for all of our scenes, and a folder named Scripts for our code. Move the files you have in their adequate location. Finally, attach a script to your main scene by selecting the main scene node on the left panel and clicking on this icon. The file should already be named accordingly, but you'll want to change the location to the Scripts folder. As a reminder, script files in Godot will come with two methods by default. The underscore in their names means that these methods belong to the Node2D class, or to be specific, they belong to Node from which Node2D inherits. The class has more methods, of course. This is just the two methods Godot chooses to pre-write for you. They will exist regardless of you erasing them from this file or not. It's up to you to decide if you want to implement a custom behavior. Generally, you will want to do just that. We have the method ready to process all the data you need to process once the current node is created, or when it's ready. The content of this method will happen only once, which is as soon as the node attached to the script has been created. Process is one of the methods used to make things happen in your game, so to speak. The content of process will happen at every frame and as fast as possible, so the delta time since the previous frame is not constant. Delta is in seconds. Be careful of what you implement here. If something doesn't need to happen every frame of your game, it probably doesn't belong in this function. As you can see in the node tree, our character and dialog UI nodes exist in this scene. In this script, we want to make it possible for the character node to change by displaying another character when it's required, and when we want dialog to display any line of dialogue instead of a template text. This is the behavior we'll implement. Since we want to affect character and dialog UI, we need to import them in our script. Right-click on them and choose Access as Unique Name. Then add them to your script like so, with the percentage sign. There are other ways to access subnodes in Godot, but this is usually my favorite way, as these lines of code will work even if you reorganize your node tree. Before we progress any further, we need a dialog, right? As I mentioned slightly before, let's add a short dialog directly in our code like so, just for the sake of testing our game. You'll want to have the name of the speaker so that you know who the character node is supposed to display, and their line of dialogue so that dialog UI knows what to display too. Open up your dialog UI scene and attach a script to it. Inside this script, you want to make it possible for this UI element to display a certain string as a line of dialogue, and the name of the speaker, which means we need to affect the value of these two nodes right here. I'm going to rename my rich text label and my label node to something more meaningful, and make them accessible as unique names too. Import them in the script of dialog UI, and that's everything we need to do for now. Why? Because we've made the connection to dialog line and speaker name, and they will now be accessible to us in the main script. Come back to the main script and create a function named parseLine and another called processLine. ParseLine will be called in order to understand the information associated with a line of dialogue, meaning we need to make it return the speaker name and the actual line of dialogue as such. ProcessLine will be called in order to process the information associated with a line of dialogue and update the dialog UI node accordingly, which we can do easily since we've established the connection to the speaker name and dialog line just before. In the ready function, we want our dialog UI to display the first line of dialogue. To do so, you can simply parse the first line and process it directly, like so. If you execute your game now, you'll notice two things. The first thing is that the dialog UI still displays the template text, meaning our code does not work. But that's fine, you don't have to worry. This is part of the coding process, it's all trial and errors. You will also notice a warning telling us that the delta parameter of the process function isn't being used. Not a big deal, but since we don't actually need the process method currently, you can go ahead and erase it. Now, why doesn't our code work? That's because if you look at the processLine method we've written, we are updating the nodes themselves with a string value. This doesn't make sense, because a node and a string are two different things entirely. What we want is to actually update the value of the text inside these nodes. Change your code to the following, and if you execute your game now, you'll see that the dialog UI correctly displays the first line of dialogue. Now, all of this is great, but if we can't interact with the game in order to progress to the next lines of dialogue, it's not much of a visual novel, right? Let's implement this behavior. In Godot, the method to process inputs from the player already exists inside the node class, and it's called input. How do I know that? That's because I read the documentation, and so should you. Add the method to your file and write pass for now. We'll come back to it shortly. We need a way for the game, or rather for a main scene script, to know where in the script we are currently. In other words, what line of dialogue should be displayed. This is very easy. You'll just need to add a variable on top named dialog index. We'll put a value of 0 by default, of course, but the starts with the first line logic should be implemented inside the ready method. Change the function ready accordingly. Inside input, we need to process the event that corresponds to the player moving to the next line of dialogue. That event does not exist inside of our game yet, but don't worry about it for now. Let's assume the event called nextLine already exists and write a conditional statement with it, where you will add 1 to dialog index and immediately process the new line of dialogue. Don't forget to make sure the next line of dialogue exists with the following condition. Now let's simplify our code a little bit. Since parseLine needs to be called before processLine anyway, we can simply add parseLine inside of processLine and remove it everywhere else in our code. Additionally, now that we have a way to know where in the dialog we are situated with the dialog index variable, parseLine doesn't actually need to have the line of dialogue as an input parameter. You could use the index as an input parameter, or preferably nothing, because you can simply recover the current line by using dialog index like so. With the current behavior, this method should rather be named processCurrentLine. Change the name and simply update the rest of your code to call this method without any input parameter. That's a lot cleaner, right? Now that our code is cleaned out, let's create the event we need for everything to function. In Godot's top menu, go to Project, Project Settings. Inside the Input Map tab, you can create all the events, or actions, you'll need for your game. Create an action called nextLine with an underscore, because it needs to match what we've referenced in our code. Then we can specify what player input will trigger this action. I'm choosing to go with the Enter key, the Space key, and the mouse left click, as this is commonly what's used in visual novels to progress to the next line. You can now execute your game again and confirm that you're able to progress to the next lines of dialogue. If you've done everything like me, it should work directly. If you have a problem for some reason, don't hesitate to reach out to me in the comments of this video. The only thing we need to add to have a basic working version of our dialogue system is to change the character sprites depending on who's talking. Now remember, we actually have 3 characters in this scene: Apollo, which is the protagonist, Phoenix, and Trucy. As for most visual novels, when the protagonist speaks, we don't need to change the character being displayed on the screen. We only need to do so when another character speaks. In other words, if the protagonist speaks, we'll switch to the idle animation of the character currently being displayed. If another character speaks, we'll switch to the speaking animation of this character. As it stands currently, we cannot change the sprite directly from the main scene, because the sprite itself only exists in the character scene. Just like we did with Dialog UI earlier, we need to help main scene interact with character scene by attaching a script to the latter. Do so, and do not forget to update the path to your scripts folder. We have no need for the process function here either, so go ahead and erase it. Add a way to directly access the sprite through our character node. Since this node has such a simple tree structure, we don't need to bother making it accessible as a unique name. Here's another way to connect a subnode to your script. Be careful, however, if you change the node tree structure and Animated Sprite 2D ends up inside another subnode, you will need to edit this line of code. If you remember, we've already created the files containing the animations for both of our characters. What we need to do now is to change the sprite frames property of Animated Sprite 2D node every time a new character speaks or changes emotion. However, these files, otherwise known as assets, need to be loaded before they can be used. Obviously, you do not want to reload an asset every time Animated Sprite 2D needs to change. That would make for a poorly optimized game. Godot gives us the possibility to preload our assets using the preload method as such. This part of the code will happen as soon as the script is loaded and processed by the engine. This means that it will happen only once, after you launch your game. In comparison, if you were to write this code inside of the ready method, the assets would be reloaded every time you create a new instance of the character scene, which of course isn't needed in our case. Once that's done, write a quick method to make the Animated Sprite 2D node change its sprite frames property. This method will take the speaker name as an input, which it can use to find the correct animation file inside of the character sprites variable. Since we only have 2 emotions, we can decide which animation should be played with a simple boolean called isTalking. If the boolean is true, we'll assign the talking animation. If not, we'll assign the idle animation. This solution is not ideal if we have more than 2 emotions, of course, but it works for now. If your game already have more than 2 emotions, you can replace the boolean by the name of the animations you want to load and use it to find the correct animation file. Now back to our main script, you'll want to update the Animated Sprite 2D every time a new line of dialogue is processed. Inside processCurrentLine, inform the character node to change its sprite using the speaker name. Execute your game and try progressing through the dialogue. We have 1 error and 1 warning. First, let's look at the warning. It turns out that name is a pre-existing variable in Godot. That's not a big deal, we can simply change it to something else, like character name. Now for the error. Apollo is an invalid index. What happens here is that when Apollo speaks, character tries to find an asset for the Apollo character, which of course does not exist since this is our main character. As I've said earlier, if the main character speaks, the only thing we should do is switch to the idle animation of the current character. Change the code to implement this logic as such. Execute your game and voila, it should work. Now if you look closely, you'll notice what we could qualify as a somewhat unnatural behavior for visual novels. As long as you don't go to the next line, the talking animation for the character currently speaking loops indefinitely. Ideally, you'd want this animation to stop after some time and switch back to the idle stance, signifying that the character is done speaking, but since we did not animate our text yet, we have no way to know when the character is done speaking. So there isn't much we can do at the moment, but do not worry, we will address this in the next part of this tutorial. Another thing you'll notice is that the idle animations look very strange. Usually humans blink after a certain interval of time, but in our game, the eye blinks are chained to each other without any break, because our idle animation is looped. Let's fix this. Let's return to the sprite frame panel of the character scene. How do we fix our problem? Well, we could simply add the eyes open frame as many times as we need in order to keep the character's eye open for some time, but that would be a very crude solution. Anytime you have to duplicate data, there's almost always a better approach. And in this case, it turns out there is, because Godot offers you the possibility to change the frame duration of a certain frame, which is perfect for our problem. Simply increase the frame duration of the last frame to 20, for example. Now execute your game, and you'll have a much more natural looking idle animation. Now don't forget to do the same for the Phoenix idle animation and you should be all set. If you've followed all the way through, congratulations, you've come a long way. I'm currently preparing the third part of this tutorial where we'll finally move on to the fun stuff. We'll be adding the text animations and the sounds to match the animations so that we bring everything to life. If you'd like to see this series continue further, I would really appreciate if you could leave a comment down below. Also let me know if you preferred the slower building live approach of the first video or the more edited approach that I used this time. I would really love to hear your thoughts. I'm planning to branch out into other topics, mostly related to video games, but also 3D modeling in Blender, and perhaps even AI, since this is the field I work in. If that sounds interesting to you, consider subscribing to the channel to see what I come up with. You can also follow me on my socials to stay connected. Thank you so much for watching, and I'll see you next time.